Hello, watchers and listeners. Keep up your learning attitude. Stay up to date knowledge. Welcome to IGBits. We train, you learn. Today, we shall continue remaining subtopics of median, which is a part of your measure of central tendency. Let's get started. I wish I would like to let you know that we have a YouTube channel, the channel name IGBits. Feel free to log into YouTube and then subscribe the channel. Your support is very important and essential for us to sustain the channel information, keep updated, and then your helping hand will support us to build the more knowledge and then sharing across, right, all the people who are like us to actually get the access and then learn the unseen topics. Okay, and feel free to share the channel to the your circle so that we can extend our helping hand to the rest of the world. Thank you all for keep staying with us and then keep help expanding our channel data to rest of the world. Let's try understand the concept of symmetric distribution. We have ungrouped data. If you have ungrouped data as a data set, what we studied is we can calculate the mean, median and mode, isn't it? So now how this data set, the data within the data set is being distributed across can be studied using normal distribution curves. This is what we can call it as a normal distribution curve. So whenever you see a curve like a bell shape, this is called a normal distribution curve. So the center line is always like a median. Now the question is that so this data set is being divided equally by the median, right? 50% left, 50% right. The curve left side curve, right, is called as a tail. This area is called tail, left tail. Okay, left tail. This curve, right, this is called right side. No, this is called right tail. Okay, one tail test, two tail test, a kind of test that also there in the statistics, which we can study in the higher when you go to the in advanced topics. Now the question is, when this is a median, so what happens, like how do you show like a mode and then mean? That we know that we have a mean and then we have a median and we have a mode. So how do you see them in this normal normal distribution curve? So whenever you have a symmetric distribution, then your mean and median mode are equal. That means like this is the only place where you have a mean and you have a mode as well. The same point. You can think same line represents both. Okay. So now the next part is look at the box plot. So in the median, measure of central tendency as a median, where we have seen this, plot the box and then identify the quartiles. First quartile, second quartile, and third quartile. So the QT basically a median which divides data into two subsets, isn't it? The number of observations left to the Q2 should be equal to right to the Q2, isn't it? That's why your this area should be equal to this area. So whenever so for the symmetric distribution, this is how you can see a mirror image. Basically, the left area is exactly same as the area under right side curve, right? So whenever you have a symmetric distribution nature of the curve obtained, that means there is no distortion in the given data. What that also means, like there is no outer layers. Outliers basically impacting your total calculation, right? So because if you when you studied the means, what we did, we considered all the observations are given to calculate the mean. Whereas in the median, we are only considering the middle, right? Middle most values for calculating the median, isn't it? So mean is going to be directly impacted with like outliers, but median is not. But this normal distribution curve basically tells you, based out of the shape, whether my data within the data set has any distortion, unwanted, or also known as outlier. Okay, does it make sense? Let's see the skew in the next topic. So let's see. Now I have a graph like this, a distribution curve like this, and then I might have like one more where something like this. Let's say I can change my color. Okay, let's say this portion is your median, and then this is also median. So if we calculate the mean might shift to the right side. This is a place where you may get mean. In a number line, right? In a number line, if you can take a number line, this is 0. This is where I think negative values, this is a positive values, right? So this is called a positive skew. This is called negative skew. So based out of your shape of the normal distribution curve, you can easily find out the skew at the right side or the left side, right? So if you look at this one, the maximum, the curve actually fall under right side to the median, right? And hence this is called the right skew or the positive skew. There is a distortion for sure. The normal distribution curve gives like not equal area under the curve from the left and right, so you always say like a skew. Whereas here your mean move to the left side of the median. So what this means is mean here greater than median, whereas here mean less than median, right? Central tendency of median are not equal. That is how you're saying. You can also observe one more, the mode. If you can really look at a mode, so can you guess like how do you represent the mode in this case? Okay, so in the negative distortion case, means like this one, right? Negative distortion or negative skew. In this case, your mode would be somewhere else here. Let me put a different color. Maybe let's take yellow, right? So my this probably is mode. So mode, median, mean. This is how it is distributed in the negative skew, negative distortion. Whereas the positive side, if you look at, so your mode somewhere else here. Okay. So whenever you have a distribution, you can easily notice how much a distortion we have, how the mean, median, mode can be seen from the normal distribution curve, right? So this skew means unwanted data exist within the data set. So your exercise is very essential for identifying the outliers and remove the outliers from the given data set to derive the some business decisions. Are you clear? But now the question is, we also study the box flood, isn't? So let's say this is a kind of a box flood. So we studied in median topic. So we know this like a left mean value, left fence is called a right fence, and then we have the Q1, Q3, and then the middle value is Q2, right? This area and this area both are equal. That means like this is a symmetry. So data distributed symmetrically, left and right to the Q2. If in case of like right skew case, how you can see this one, there is a two possibilities. In the box, your Q2 would be maybe here, and hence the maximum area you can see right to the Q2. This is called a positive Q, positive skew or positive distortion, isn't it? Similarly, you can also see negative distortion from the box flood. In this case, your Q2 to the right, the area left to the Q2 is maximum comparatively. This is called negative skew, right? This one negative skew. It's like a negative distortion. Other words. Okay. So there's one more thing. Though your box distributed equally, and then Q1, Q2, and Q3 are exactly seems symmetry. However, you have the length, right? The min length and the max length. If you like this, left fence and then right fence. Other word, right? When you have this one, what happens is like this is a positive skew. This also you can consider. Similarly, we can see the other case where let's say your min is very max, gone left longer distance, right? This basically negative skew. So this is how you can understand from the box plot or the normal distribution how the data is being distributed. If it is not a symmetry distribution, then what kind of a distortion that you might have, and how you are going to identify that the distortion, remove them from the given data set is very essential for us to understand, derive some business conclusions. I hope you are clear. This is a very good concept. Okay. So when you go and learn the a bit of advanced topics of statistics, and then these graphs are very you know uh, useful for actually understand the data set and then derive something out of it. That's what I was trying to reiterate in a short. A simple question: we studied a median. If at all I ask like why do you need a median, I think median means like a measure of central tendency, but why do you require to do this? What is actually you're trying to achieve? Simple. If you look at the mean, arithmetic mean, what we did, we consider all the observations for calculating the mean, arithmetic mean, isn't it? So that means like the when you consider all the observations, the data within the data set might be having like an outer layers, unwanted data, the distortion data. That means like this is going to be impact your arithmetic mean value, correct? Whereas in the median is not depending upon the extreme values, outer layers. What it what it takes from the data set is only middlemost values, right, from the observation, the magnitude of middlemost values. So that's one advantage. So straight away you are taking the extreme values out. That's the first thing. Next one, we know that the median divides the data set into two equal parts. So this means 50% of data lies left to the median, and then another 50% right to the median, right, in the order data set. What this means, like whenever you wanted to divide the data equally as a two sets, as subsets, then obviously median is one best method. Second thing, This also helps you to understand how the data is being distributed, left to the Q2 and the right to the Q2. These are the two things that you can get it from the median. Say as a note, consider this point. Based on specific need and nature of the data is given, we may need to choose either the mean, median, and mode. Okay. Thanks for watching. Please like, share, subscribe, click on bell icon, and leave the comments. Thank you all. Stay tuned to next session. Have a good day. See you in next class. Bye bye.